If you're a parent watching this, you've probably experienced this situation before. Your athlete tests well, they look fast in training, they move well in drills, but then the game happens, and suddenly they don't separate. They don't pull away, they don't look as fast as the numbers suggest. That disconnect is very frustrating. And the most common reaction is to assume something is wrong with the athlete. They need to be trying harder. They need more speed work. They need to condition more. Here's the truth that surprises most people. Speed usually doesn't fail because an athlete lacks ability. It fails because the way speed is trained never teaches the athlete how to use it in real conditions. Let's start by clearing something up right now. Testing is not the problem. Speed testing, things like 10-yard splits, 40-yard dashes, pro agility, are incredibly valuable. But they answer a very specific question. What can this athlete do in a controlled environment? That's important. But games are not controlled environments. That's the big issue. Games involve fatigue, chaos, imperfect positions, opponents, decision-making, and timing pressure. Testing shows capacity. Games demand application. And those are not the same thing. This is where most confusion comes from. Parents hear, my athlete is fast. Their numbers are good. They should be flying on the field. But speed isn't a switch you turn on. Speed has to be expressed. And expression demands on when force is applied, from what position, after what action, under what level of fatigue, with what decision requirement. If training never teaches speed in those conditions, it stays trapped in testing environments. Here's a pattern you'll see in a lot of programs. Speed work happens early in the session, when the athlete is fresh and in straight lines, with predictable timing, with no decision making. That builds capacity, but it doesn't build transfer. Games rarely ask athletes to sprint fresh, upright, and unchallenged, and on perfect timing. Speed in games usually happen after something else. And that's where transfer breaks down. Think of speed like a skill, not just a physical quality. In games, speed usually comes after braking, after changing direction, after reacting, after contact, and under fatigue. If training never places speed after those actions, athletes never learn how to access it. That's a sequencing problem. And sequencing is one of the most common missing pieces in youth development. Let's make this concrete. Bad sequencing looks like this. Sprint first, everything else later. Speed trained in isolation, agility trained separately, conditioning done randomly, no connection between pieces. Athletes get faster in tests, but never learn how to connect speed to sport actions. The system doesn't break, it's just never complete. Good sequencing teaches athletes how to reaccelerate after braking, how to maintain posture under fatigue, how to express force when timing isn't perfect, how to access speed late, not just early. This doesn't mean every session is chaotic. It means speed is placed in the right order, not just train hard. Fatigue changes everything. It alters mechanics, posture, timing, coordination, decision-making. An athlete who looks fast early in game can look average late if they've never been taught how to maintain output under fatigue. This is not a conditioning issue. It's a development issue. This is where many programs go wrong. They notice speed drops late in games and think, we need more conditioning. But fatigue without structure just reinforces poor patterns. If an athlete hasn't learned how to reaccelerate efficiently, how to manage posture, how to apply force economically, more fatigue just magnifies the problem. Here's another truth most parents don't want to hear. Game speed is often about when you go, not how fast you go. Late decisions erase speed advantages. An athlete can be physically faster, but arrive late because they read the play slowly. They hesitate. They don't anticipate well. Speed expression is tied to perception, and perception is rarely trained intentionally. Some programs try to fix this with reaction drills. Random cues, lights, a bunch of quick responses. Those look impressive, but often miss the real issue. Decision-making in games is contextual. It's based on patterns, anticipation, familiarity, positioning. That has to be layered in over time, not forced randomly. But here's the hard truth. Many programs do a lot of things right. They build strength, they build power, they build straight line speed, but they never integrate those qualities. Everything stays siloed. Without integration, capacity stays unused. Real development systems don't chase drills. They engineer transfer. They progress athletes through capacity building, controlled application, contextual application, fatigue-aware execution. Each layer builds on the previous one. Nothing is random. If you want to know whether a program is actually addressing transfer, ask these questions. How does speed show up later in sessions? How does training change under fatigue? How is speed connected to braking and reacceleration? How does decision-making get layered in? If those answers aren't clear, transfer is being assumed, not trained. As competition increases, margins start to shrink. At higher levels, everyone is strong, everyone is fast, and everyone tests well. The separator is usable speed. Athletes who can apply speed under pressure separate. Those who can't, plateau. Testing matters. Capacity matters. But speed only shows up in games when it's trained to survive context, fatigue, and decision-making. That doesn't happen by accident. It happens by design. If speed hasn't been showing up when it matters, the answer usually isn't effort. It's structure. It's programming.